Assalamu alaikum, dear students. I'm Dr. Mumtazul Islam, and now today we will discuss the irreversible hydrocolloids, and these are alginate. The reversible hydrocolloids are agars, and these are the alginates. Starting our lecture, alginates. If we see the presentation, in which form they are presented to us, is the powder with different tastes and colors. So powder with different taste and colors is its presentation form. It is presented in the form of powder, and powder having different tastes and colors. Now, slow setting and fast setting, two other parameters are there. Depending upon its setting characteristics, two types are available. One is slow setting and the other one is the fast setting. Fluidity, its fluidity, flow, varies also from product to product. Large tubs you may see, but nowadays they comes in plastic bags. In previous or in other countries, they may be present and they may be presented in large tub, but these tubs are not much enough large. These are of about 2.5 kilograms. Sorry, 2.5 kilograms. You can see the 2 point. Sorry, I am taking tea at the same time. So this is 2.5 kilograms. Is it clear? Yes, 2.5 kilograms. So tubs meet not a huge tub. In dentistry, 2.5 kilogram is like a tub. It's like a box of 2.5 kilograms. Miring spoons like teaspoon and other spoons. Miring spoons and miring cylinders are supplied by manufacturers. Usually they are supplied with the material. Sachet of powder are also available for single impression. These are the presentations of this material. And what is this material? This is alginate. And these are the irreversible hydrocolloids. So denser materials, if present in, and obviously are present in alginates, especially in tubs, and they usually settles down to the bottom. So if you have any tub or even a box, invert the tub or box before use to mix the separated particles which were settled down into the base, to the bottom. Inversion of the tub also prevents compaction of the material because the material will be compacted or in a compact form. So when you invert it, it will come to its original shape. Now it doesn't matter much, but it is wise to invert the tub for two reasons. Number one, that uh, material uh, which settles down to the bottom, and the particles uh, which were uh, present in a compact form will be uh, will be separated through this inversion. Measured volume of powder and water then mixed. And what is this measured volume? We can see it, and it can be made a assignment for you people, that you go and search that how much powder of alginate is desired to be mixed with how much quantity of water. Now for mixing, a flexible mixing bowl and wide bladed spatula is needed. Wide bladed spatula you people have in your own dental kits, and the flexible bowl also is present in your dental kits. Rapid spatulation to make for mixing, you have to spatulate it like stirring of your tea, of your sugar in your cup of tea. So spatulation is like this. Rapid spatulation converts alginate sol sorry produce alginate sol of creamy consistency. Gel will come after or afterwards, and when a gel is formed, it will be time to take the impression. Now composition and functions of ingredients are available in this uh, table. Sodium or potassium salt of alginic acid is 11 to 16%, and it is the main reactive ingredients. Form sol with water and become cross-linked to form gel. Then again the calcium sulfate hemihydrate, because it takes water and convert into dihydrate. It is 11 to 17%, and it is source of calcium ions which cause cross-linking of the alginate chain. Sorry. Then comes sodium triphosphate, 1 to 3%, and it used to control the working time. Then inert filler such as diatomaceous earth. Diatoms. What are diatoms? Go and search Google for diatom. And what is diatomaceous earth? It is filler. And these are 65 to 75%. And what they provides, as all our fillers provides body to the any material and enables easy manipulation. Then reaction indicator, it may be present in some products, not in all products, and it gives a color change when setting is complete. Now, monovalent sodium as sodium alginate replaces divalent calcium. Sodium has Na plus 1, and sorry, calcium is Ca plus 2. Cross linking of alginate chains, sol turns into gel. Cross-linking of alginate chains turns sol into gel. And what is cross-linking? Already described, but again for your sake, for the sake of your understanding, I am trying my best that if we see these are if we see that these are our these are our chains of sodium and cross linking if occurs in this in these chains, that is like now cross linking for the cross linking through this, if the cross linking occurs like this, then what we have, it is a cross link structure, so it turns sol into gel, more compact system and gel form. If these are present like this, then it is a sol form. Gel with increasing cross-linking attain plastic properties. As this cross-linking become more and more, what will happen? It will be more compact structure and ultimately it turns from elastic to plastic. It turns into uh, plastic state from the elastic state. Now sodium phosphate reacts with calcium ions and retards the reaction. Sodium phosphate reacts with calcium ions and stops its reaction to happen. When all the sodium phosphate from trisodium phosphate reacted calcium ions available to the reaction, sodium alginate reacts with calcium ions from gypsum to form calcium alginate. This is the setting reaction. Now, it is an ideal impression material, sodium alginate. Why? Because after mixing it go through an induction period. Induction period, like your induction period, you people have passed the FSC and then underwent ETA exam. After that, a long induction period you have seen or you have gone through that induction period. Like that, after mixing, you are prepared in August or in November for your classes. But the induction period was so long that till now you are not able to say anything about your induction that it is proper or not. So that is the induction period. Through unchanged viscosity, that I can say that you are also in an unchanged state. Neither you are a medical student nor you are a student who have passed the FSC and comes toward the and went to the medical school. So you are in between. So we are trying to take you people out from this induction period and put you people into the true medical student period. So Advantage of material and advantage for you people is that you have adequate working time before your exams because you have no classes regular, no outings, no other things. So this is the advantage also present for impression material, and we can say that it is an ideal impression material. It has an adequate working time before a rapid setting. When it comes to setting, whenever the calcium ions available, it readily sets. So low viscosity increases its fluidity. It's another advantage already described, that if a material is of low viscosity, it's more fluid and it can take more impression from the minor areas uh, like you can say minor areas like subgingival area and other things, uh, gingival subgingival areas. But it is a disadvantage for sulcus lingual impression, especially lingual sulcus, because it flows away and the impression is not obtained at lingual sulcular level. Pseudoplasticity is present. Pseudoplasticity means not true plastic. To some extent is again its advantage, because if it is a plastic material, you will be in a state of mm, not taking the complete impression if it is true plastic material. Plastic means rigid. Now again, it is a mucostatic material. Mucostatic, not the mucocompressive. Is it clear? Yes, it is a mucostatic material, not put much force to the tissue. Setting can be controlled by operator by using cold or warm water. You also can control setting of this material through using cold water or through warm water. If we use cold water, the setting will be delayed. If we use warm water, the setting will be rapid. Setting is rapid near oral tissues than tray. Why? Because the tray is cool or cold and the oral tissue is warm. Simple. Tray movements during impression causes distortion. Unlike agar. In agar, if we moves or if we provide some movements to the tray, so no distortion may occur. But if we move tray or give a movement to the tray during impression, then our impression will be distorted. Now viscoelastic material, again it is viscoelastic material, acts like shock absorber. Degree of cross linking continue after material sets apparently. Degree of cross linking continues after materials. We say that this material is set, but cross linking is going on after that setting. So that is why we or recommendations are that to obtain elastic impression, remove it after 1 or 2 minutes, not too early. If you want to obtain elastic impression, remove it after 1 or 2 minutes. So mechanical properties are also poor, like agar. Poor tear resistance is also there, like agar, at especially interproximal between two teeth and subgingival and deep undercut areas. Permanent deformation due to viscoelastic elasticity and tear, as it is a viscoelastic material and low having low tear resistance, so permanent deformation is due to the viscoelastic property and the less tear resistance, and it can be reduced by large bulk of the material if used with a 3 to 5 millimeter space between tissue and the tray. If we have a tray that have a space of about 3 to 5 millimeter between the tissue to be recorded and the tray, then we have this permanent deformation less. Syneresis and imbibition produces dimensional changes. Syneresis always already explained, and imbibition already explained in agar agar. Model should be cast as soon as possible. So model must be cast as soon as possible due to the syneresis and imbibition, which are the properties of these materials. Impression can be covered with a damp napkin like alginate. Impression can be stored covered with a damp napkin. For details, you can see my previous lecture about agar agar, the reversible hydrocolloids. Now, applications where it is applied in prosthetics. Impression for partial and complete dentures can be taken through alginate impression material. In orthodontics, impression for study models and appliances, either removable or fixed, we can take the impressions through alginate impression material. Rarely used for impression of crown and bridge. Why? Because of its poor tear resistance. But usually it is not followed. Crown and bridge impression nowadays is a practice to be taken by alginate impression materials. Immersion in aqueous solutions is this the protocol for the decontamination, sterilization type of thing of this. Decontamination not mean sterilization, but to eradicate uh, the harmful objects and materials from that. Decontamination. Now, immersion in aqueous solution is one of the mode. Hypochlorites and aldehydes, formaldehyde and glutaraldehyde, are used for immersion. the aqueous solutions of hypochlorite and aldehydes. Then a short-term immersion treatment only for 10 minutes is advised for hypochlorites. Hypochlorite sprays are also available. Rinsing and short dips in glutaraldehyde are also advised. Poured cast immersed in hypochlorite solution for 10 minutes is advised for decontamination. Now, a combined reversible irreversible technique is there, as nowadays we have not facilitated and special trays with tubings for cooling the agar material are not present, not available. So it is alternate to it is a technique which can be applied for taking a good impression through alginate and agar. Loading the tray with alginate and syringing agar to region to be recorded. As agar can reproduce or can take impression of details of surface with minimum complications. So the setting facilitated by alginate having no need of water cooled trays because alginate is sufficiently cool material. Disadvantages are poor dimensional stability and poor strength. Tensile bond strength above 50 kPa between both is kPa mean kilopascal between both is required according to ISO specifications. Dimensional change after 20 minutes should be less than 1% at 23 degrees centigrade and 95% and at 95% humidity. Hybrid material silicone polymers incorporated in modified alginate. Silicone polymers, when incorporated in alginates, then a hybrid material is formed, and these are also called as modified alginate. Two-phase system with color contrast are available. Mixing is difficult due to the difference in viscosity. Marginally good fine details and tear resistance are there, but poor dimensional stability is a factor which cannot be eliminated. Cast should be poured immediately. And a big thank you very much for your patience.